everyone. So those who are online, thanks for joining for the webinar. My name is Shivam and we will start in a couple of minutes. In the meantime, please introduce yourself. Let us know about your expectation. Let us know about your background. Let us know about the basics of like where are you? Are you a beginner in Kubernetes and Docker, or this is something you might be already working on and you want to get certified? So where do you stand? Right. So do use the chat window and do let us know about that. We will start in a couple of minutes. And Mamta, your webinar, your video camera is on maximize and your screen is not visible. If that is what you want, right? Please do check that out. And you are on mute.
Sorry, so screen is not visible.
Yeah, now we can see the wallpaper.
Yeah.
Perfect. Now we can see the slide deck. Yeah.
Thanks, Shivam. So hey, hi everyone. Please introduce yourself. At least tell us your name, what exactly has got you here today, and what you're expecting from today's session.
You can use the section called as questions over there, and you can ask questions. You can let us know about in that, right? If you're searching for the chat window, use the question section.
Hey, hi Parikshit. Good that already you're working on Kubernetes and you're looking for knowledge to do CKA certification. Nice. So you're already preparing for it, or you're planning to prepare for it? What's your target date to get certified? Any plans in mind? Good, Naveen. At least you're taking initiative. You're beginning your transition to containers and Kubernetes. That's good to see. Amar is saying I'm in managed compute infrastructure, VMware, Windows, Linux. Okay, beginner to Docker and Kubernetes. Nice to know. What about others? Quite a few people are there. Please introduce yourself and tell us how you're doing today. Hope so everyone is safe due to Corona and all, but still in this worst situation, everyone is trying to keep them busy in some of the other activity. So we have a webinar, you people have joined in. It's good to see that. Looking to work on Kubernetes and then get certified. Okay. Nice, Parikshit. Target is always needed. So if you can set a date, you will try to achieve it. Okay, Kishore says he is into ITSM delivery. And Saurav is already preparing for CK. Good to know that. Hey, Sarvesh, working in Ericsson. You're working on the network side. I too come from a telecom background. So you people are using Kubernetes in telecom these days in LTE projects, a lot of telecom projects. Kubernetes is widely used. So we are waiting for a few more people to join in, and maybe we'll start in 2-3 more minutes. Okay. So Kiran, your .NET application is running in virtual machines and you people are planning to transition that to containers, is it? Kiran is saying that he's a .NET developer having around 7+ years of experience. Nice, Asif. You're AWS certified, you're working on VMware, and you're gaining knowledge of KTS and get certified. Nice. So quite a few people are transitioning their career. I'll be talking about what's the demand of Kubernetes jobs in the market at this point. So that would be add-on stuff. We will look into technical aspects. We will cover some topics, but we will also look into the demand and what exactly we need to learn to get certified as a CKA or a CKAD. A lot of people just planning to get certified. Nice. So Ram, which company you work for? Hope you don't mind sharing that. You're working in telecom domain. So we are already 5 minutes into the session. So should we start? Shivam and Kopal, what do you guys suggest? Should we start the session?
Yes, Mamta, I think we should start now.
Okay, thanks a lot. So yeah, let's start today's session. So whenever we think about Dockers and Kubernetes, I'll just switch off the video so that you guys don't get distracted too much. So today we would be discussing about how to accelerate our career with Docker and Kubernetes. If you really look into the job opportunities which are there in the market, that has exponentially increased for containers and containerization orchestration platform. So that's the reason a lot of people are getting certified in administrator role or getting certified as an application developer as well. And quite a few number of people are doing Docker certified associate certification too. We would first look into our aspect of doing what exactly we need to learn some building blocks and then start. So Kopal, if you would like to introduce our company to them, quite a few number of people might be new to the name Tech Scalable. If you can introduce the name of the company, and then I missed your introduction part.
That's one thing, certainly. So hi everyone, thank you so much for joining in for today's webinar. So just to give you a quick intro on Tech Scalable. Tech Scalable is a training and a consulting company. So we deal in both. We do corporate trainings, we do individual trainings, which we recently stepped into. And yes, we do handle the consulting projects as well, where we support companies in terms of when in their projects. So now just to give you a quick brief intro on Mamta's profile. So Mamta is one of the co-founders in Tech Scalable, and she comes with 16+ years of experience. And she has worked on different cloud platforms like AWS, Azure, and Google. So she has a hands-on experience on migrating, automating, and optimizing mission-critical deployments in various cloud platforms, leveraging configuration management, CI/CD, and DevOps tools like Docker, Kubernetes. And today she is going to present a webinar on Docker and Kubernetes. So Mamta, over to you now.
Thanks, Kopal. Sorry, I missed that in the beginning. So yeah, we would start with understanding what should be the path of learning Docker and Kubernetes, and then I'll take you to the first topic. Last time also we started with microservices. So we would be discussing about microservices. We will look into one of the very famous app. Everyone would have heard about Swiggy if you're based out of India, or any food booking application where you order the food and you get the food delivered to your home, like Food to Go app it is normally called as. So we were looking into the architecture of Food to Go application from microservices perspective and monolithic perspective. So we will look both the architectural plotting of the design. Then we would understand with microservices why containers always come into picture. And from there, we would try and understand what drawbacks does container have that we are bound to use Kubernetes along with it. Why we are forced to use Kubernetes. Why does container doesn't satisfy all the needs and requirements. We will not spend that much of time in these two topics. We would spend some amount of time on this. And then at the end, we would spend some time in understanding what all topics should we prepare for CKA and CKAD, what's the percentage, how the exam looks like. Exam was recently upgraded in November 2020. So we would look into the newer pattern of it. And after that, we would be also focusing on job opportunities which are there. Job aspects. We offer courses of CKA and CKAD. So we would also talk about that. And I would like to spend some time, because a lot of time when people hear this word CKA and CKAD, they think that we are just delivering sessions to get people certified. But that's not something very true with us. We have something extra in both the courses, which makes you job ready and all. So we would discuss about that as well. So this would be the agenda of today's session. Let's start with our first slide, which would be about microservices. So here, when we start with a monolithic application, the first thing which we have to focus on is how does the architecture look like? This is a food to go application, Swiggy type of application, where a customer can book food from a restaurant and that gets delivered to that customer. So we have a huge amount of logic sitting in the center. We have a database at the backend. So how does our application look like? Application would have a front end. Application has a middle tier, which is actually the business logic. And then there is a database at the backend. This is how the application stack of most of the applications look like, right? You have a front end where you receive the request. Then you have a business logic, wherein this is the core or heart of your application where all logic resides, and then you have a database. In case of monolithic, database is always a common database, a single instance of database which is referred by n number different types of business logic inside that. Whenever you see a hexagon like this, that defines the boundary of your application. Let it be a monolithic application or a microservice application, these two words, when they come like into picture, monolithic means mono is single. Monolithic means a huge bulky block that is called as monolithic. Micro and services. When we have a lot of logic fit in and we want to break them into individual smaller logics, that would be called as microservices. So this application design is of a monolithic app. Why I'm saying it's a monolithic app? Front end is sitting here, back end is sitting here, but the entire business logic which is there, that is deployed as the heart, as a center, as a single executable. So this defines the boundary, first thing. This is the boundary of your monolithic application. On the boundaries, you see some boxes. They are called as adapters. What does an adapter help us to do? Adapter helps us to connect to varied other services at the backend. Like I have a SQL adapter which helps me to connect to the backend SQL database. I would have an adapter or a logic fit in here which would help me to talk to the front end. I have a messaging application, I have an email notification service, I have a payment services. These are third-party services with which I'm integrating. And for that, I would need an adapter. So these adapters are helping me connect to third-party services. That is what we are doing. So that was the second point, that adapters are important. Now, the logic which is sitting inside this dark yellow box, that does a lot of functionalities. It's not playing one part, it is playing a lot of functionalities inside that. Like if I want to order food, there would be an order management service. Once the order is created, restaurant will get that order. An order ID is generated. Restaurant management service is there. Then once the food is ready, It will have a delivery management service, the courier guys, those who come and deliver at our home, right? And in between, when the order has to get created, you got to make payment, and from time to time you will have the billing and you will get notification as well. Notification like the food is ready to prepare, food is getting prepared, the person has reached the restaurant, and the person is arriving at your place. So who all are accessing this application? The restaurant guy is accessing the application, the consumer who is booking the food is accessing the application, and the courier guys, those who have to deliver the food, are accessing the application. Now the biggest pain point. Let me clean the slide and come back again. Okay, so the biggest pain point with monolithic application is they all are sitting together. Two important words: tightly coupled. What does this mean? When I have all the logic sitting together and they are just one function call away from each other, they are very closely coupled to each other. They are knitted so tight that if a single change over here is done, it can impact any of the logics sitting inside that box. It's just not that a change can impact, because this inside box will produce a single artifact, or people also call it as executable. This is a Java-based application, a Java Spring Boot application, which I'm talking about. So we would produce a jar or a var file as the output. If you take this jar and the var file and you deploy that in a virtual machine, if I'm deploying the jar in the VM, entire logic will come up together. Imagine that there is a bug in the order management service. The entire system will go down at once. It's going to impact the entire system. Because tightly coupled, they are going to have a huge impact on each other. Let it be a implementation of a newer feature causing that impact, or some functionality not working causing that impact. So that's the drawback of having a monolithic application. The jar file would be very bulky. Implementing a CI/CD pipeline becomes challenging because there are multiple teams, those who are actually delivering their code to the same code repository. Let it be a restaurant management change, we have to build the entire system once more. The jar file has to be completely built from scratch and then deployed. It's not an individual component which gets developed, tested, and deployed. It's a single piece of executable which gets developed, tested, and deployed as a single executable. So here, if we see a microservice-based architecture of the same application, so the same image is transitioned in a microservices way. Order management service is a separate hexagon. Restaurant management service is a separate hexagon. A kitchen management service is a separate hexagon. A delivery management service is a separate hexagon. Accounting services, notification services, and these are the API gateway where the courier guys, the consumer guys call the API when they try to select of booking food and all that stuff. An API get called and it directs them to one of the services. And restaurant guy has a specific web UI to log in and check the details. So when we move from monolithic to microservices, we have to first divide our logic into small functionalities, a complete functionality. Order management is one functionality, which is complete functionality would mean that I can develop this separately, I can test this separately, I can deploy this separately. It may have dependency with restaurant management service, but it would be like a API call. Just imagine that when you are calling a function called as create order, there is a function inside order service called as create order. When you call this function, what all attributes will you pass to? Every small bit and pieces of the code has to be understood so that we can break that monolithic into microservices. In case you're starting from scratch developing an application these days, you would be building microservices. But in case you're having already a monolithic application, then you got to break them and have microservices based architecture, we would attain a lot of advantages. The scalability of microservices based architecture is high, because in case a single bulky block was there, when I was scaling, all the instances were scaling. Now imagine IPL matches are going on in India. It's a cricket tournament which happens. So in this season, the applications or the food selling app, they come up with a lot of offers. If someone hits a 6, you get a 50% off vouchers and all. So a lot of people are browsing and looking at the restaurant, but not very few people are actually ordering the food. So the amount of traffic coming to the front end is very high compared to the amount of traffic going to the actual individual services. Create order service would get request very less, but restaurant service where people are filtering the restaurants within 5 kilometers, Chinese restaurant or Italian restaurant and all, right? So filtering of the restaurants may be high. So people are looking into restaurants but may not be ordering food. So individual scalability of individual instances is not possible in case of monolithic. I have a single bulky block. If I scale it to 2 instances, order service, restaurant service, kitchen service, delivery service, everything will get scaled. But when we are in microservices based architecture, I'm getting a lot of orders. I'll just scale this into multiple instances. There are few things called as X, Y, and Z scaling. Let me just tell that. That's very good in terms of microservices. I have X-axis scaling, Y-axis scaling, and a Z-axis scaling when we create monolithic to microservices. X-axis scaling is when you have multiple microservices, single microservices running in multiple instances. Like this is also order management, this is also order management, this is also order management. All are serving the same order management microservice. I'll fit in a load balancer in front of it and people will route traffic here and it will get distributed across the instances. This is X-axis scaling. When multiple instances of a single service would be running, that is X-axis scaling. When we talk about Z-axis scaling talks about that you will have a logic. Normally we call it as a router. You will have multiple instances like this serving order management. But that order management will only be served on a specific condition. That means the routing of the request will have some condition-based approach. Now, a request for order management is coming. Create order. What would be the input to it? I would have a consumer ID or a user ID. Let's call that as user ID. Guy who is actually ordering the food. So dependent, because I have millions of customers, handling them becomes a challenge. And what we would do, we would route a customer request coming from 1 to 1000 would be handled by this. 1001 to 2000 would be handled by this. 2001 to 3000 would be handled by this. Like that, I will be having multiple instances. In this case also, you had multiple instances, but every instance was handling similar type of traffic. There was no differentiation between what we would be sending to the first instance or second instance or third instance, right? But here we would be segregating our load and then routing them to the correct instance. So this is called as Z-axis scaling. Then what is Y-axis scaling? This should be the first step, but I'm telling it at the last because that's the most important one. The monolithic application has order management and has restaurant management both. So order management would be taken out from here and would be deployed as a single microservice. That is Y-axis. When I break my monolithic application into individual services, one day my design will be looking like this. Restaurant management would be sitting standalone and order management would be sitting standalone, and they both would be interacting with each other through the REST APIs. So this is called as Y-axis scaling. So X-axis scaling, Z-axis scaling, and Y-axis scaling. So the journey from going from monolithic to microservices, we come across these stuffs. As a developer, we have to go through this journey. But many a time as an administrator, you will think that Mamta might be talking so loud about development activities. But as an administrator also, you got to understand these terminologies. These terminologies have become so important in the market. You would find keywords like cloud native architecting, microservices, monolithic, and all that too much frequently used. We need to understand these terminologies. You might not be understanding the working functionality of a code, but understanding those terminologies is very important. So we have to understand about monolithic and microservices. And these microservices, because they are mini application. Imagine my Food to Go app was utilizing a 2 virtual CPU and a 4 GB RAM. I was deploying that in a VM. Now when I've broken that into 4 parts, I'm utilizing 0.5 virtual CPU and say 500 MB of RAM. And maybe few of the least utilized ones like the notification service, the accounting service would be utilizing or needing resources very less compared to the other services as well. So I can't afford to run them in virtual machines, because what would happen in case I run them in virtual machines? So when we think about virtual machines, you have the hardware which is shared or which is virtualized, and on top of it you have operating system plus hypervisor or hypervisor alone, and you deploy a VM. VM has a full-fledged operating system, the guest OS. This is pretty bulky, just not in size. It needs some amount of dedicated resources so that it can function. The OS will run, then only the application on top of it will run. So my application needs are 0.5 virtual CPU and 500 GB of RAM, but my OS needs 1.5 virtual CPU and 1 GB of RAM. Don't you think it's just very not good on our part to deploy that application in a VM? Actual application needs are so less compared to our operating system. Here you are feeling as if you're just meant to run our OS, but that's not our agenda, right? Our agenda is to run our application. Our agenda is not to run our operating system. But this guy can't be taken out from here. Why? Because if this layer is not there, I can't boot my application. I will not get a file system for my application. So what people did when they moved to containers, they shredded or shrink this layer of the operating system. Here it was called as guest OS. Here it is called as base OS. Whoever has not attended the previous webinar, I would not be going into the Docker topic that much. I would request people to go back to our previous webinar and listen. It doesn't look nice on our part to keep covering the same topic again and again. I know could be there are some basic questions of yours which may not get covered today in case you're new to Docker. But imagine that we keep doing the same thing, it becomes difficult on our part as well. So someone from our team can help these guys with the link of our previous webinar. That would be really helpful. So we would just discuss the difference between these in a very high level point of view. So here also we will have hardware, we will have operating system, but we would have one more layer along with it, which would be the containerization platform like Docker. And we would create containers. Containers will be like virtual machines, but the operating system part would be very less in that. If this is a 8 GB usage of disk for this OS with 1.5 virtual CPU and 1 GB RAM, this base operating system might be 30 MB in size and would be needing 0.25 or even less than that. I would say not even 100 millicore and 100 MB of RAM. The OS processes are so less. Why so less? Because my operating system doesn't have to do anything apart from booting and providing file system. Rest, all the modules are shredded. They are not present in that operating system at all. And I run my application. So this application, when we are saying this is nothing but the microservice, right? So microservice is the way of architecting your application, and container is the way of packaging and deploying that application. So we would be packaging our microservices not like a VM image. We would be creating a container image out of it, and we would be deploying that into our, could be a Docker host machine when we are working on standalone servers, or could be a cluster, any of the choices. So we would look into the drawbacks as well of containers, why Kubernetes comes into picture. That understanding should be there in everyone. So this picture depicts that when we are moving from monolithic and we are transitioning to microservices, we will have to package our application as containers. And containers are not as stable as virtual machines. In VM, the stability came from guest operating system because it had processes which had dedicated resources. It was almost near to impossible to kill a virtual machine. It's very difficult to kill a VM. But if I have a container is nothing but a process on the OS level. They just literally fool us. Why Docker became so famous in market? Docker came up with good commands. Like if I say Docker run, it will go ahead and talk to the kernel on my behalf and create an isolated environment for the process which we are starting. But end of the day, it is nothing but a process running on the operating system level. But it is isolated. Isolation brings the difference between running multiple processes in a system in a non-isolated environment and running multiple processes in a system in an isolated environment. How that would be different. If they are running in an isolated environment, they would not trouble each other. They would not eat up each other's resources. They would be running inside their own isolated environment and they would be happy running there. I can dedicate resources and log some amount of resource to this process. I can say whatever processes are running inside this container, they would be not going beyond one virtual CPU and say 0.5 GB RAM. I can dedicate that amount of resources. They have done nothing very different. Namespaces and control groups were used in VMs as well. The same funda was utilized in containers as well, but they made our life simple by just calling these APIs, which were very simple for human like us to work. I was working with Alcatel-Lucent and we were working on Linux containers. I had to struggle working with kernel level stuffs. It was really difficult on our part because even though we are engineers, I had never worked with Linux kernel before. Going to the kernel level, isolating the processes, isolating the network, creating a separate mount environment, creating a separate kernel environment for it. So whatever processes are running inside that, they are not seen to the other neighboring processes. Their disk, if I mount here, that would be only visible to this container C1. It would not be visible to anyone else. So that isolated environment creation is a big challenge. And when Docker came up with simple commands, on our behalf, it went ahead and like fluently or very easily, amazingly, they created those containers in an isolated environment. And that was the changing point in the industry. When people got those things with lot of ease, people started to work with it. It was not that people didn't know how containers are working. Google engineers are using Linux containers from day one, but they are also doing it on the kernel level. A lot of people adapted containers only when Docker came into the market because it simplified the way of working with it. But it has a disadvantage that it is unstable. It is born to die. It can be killed very quickly. Someone has to literally sit and see what's going wrong with it and monitor that and make sure that it is not dying. And in case it is dying, bring that back into action. That was not the capability of Docker. Docker as a company had put a lot of effort in creating this layer which could make our life simple. But they had not predicted that it will catch like a fire in the industry and everyone will be running behind Docker. 2015, they thought that they should start working on Docker Swarm. Kubernetes was already there with Google. They contributed that to the open source community. And this guy is so intelligent that it can manage thousands of containers at same point in time. Make sure they are highly available, make sure they are scalable, make sure that they are never going down. It can maintain the entire desired state of our cluster. So that's the advantage of it. But when we are working with Kubernetes, you got to have a containerization platform underneath. Kubernetes can manage containers. Kubernetes doesn't have the ability to create containers. So as a developer, we will be creating our microservices-based applications image. People call it as Docker image. Docker has become like a synonym for containers, right? People create Docker images and we pick those images, go to Kubernetes cluster and deploy our application. So we can keep this image in a central location. Container registry also plays an important part over here. So I would have a cluster in any cloud environment or on-prem, anywhere I have several nodes in which I would be deploying these containers. But for that, I would need image of the microservice, right? So in the cloud somewhere, imagine that we have hub.docker.com or Azure Container Registry, Google Container Registry. A server where we can keep our images is called as a registry. So how we keep packages in repositories, like that, we keep images in registries. So registry is a source from where you would download your container images and would deploy them in the Kubernetes cluster. So container registry is also a basic building block. So two basic building blocks we know now. Docker you need a registry server and you would need a cluster. We would create a cluster. We would deploy containers which are created out of Docker commands, and we have pushed the image in the registry server. From here, we would pull and we will deploy the application to our cluster. So that gives us an advantage. We would be handling the microservices-based architecture in this way. Imagine that when I'm translating my monolithic app to a microservices-based architecture, right? If I take you back to that diagram, you can now say that this would be container C1, this would be container C2, this would be container C3, this could be container C4, this is C5, and this is C6. They are individual. There are multiple other containers as well. So we would be deploying each of the individual microservices as C1, container 1, container 2, container 3. And whenever I need more instances, I'm getting more traffic to it, I would be doing x-axis scaling or z-axis scaling. Y-axis scaling is already done here because we have broken down the monolithic into microservices already. Some challenges with this when containers are running, lot of containers are running. Let's focus on that. So if we have a bunch of containers, I have my order management service running in a container, my customer management service or consumer management, my kitchen management service. When they got to interact with each other, they got to understand where the other guy is running. Every container is having its own IP address. And it has a port number on which the application is listening. But when a packet has to go out from the order management to the consumer management, or rather I would say the other way around, from the consumer management to the order management service, consumer management should know the present IP address because containers are not stable. If you kill the process inside the order management, whatever the primary process starts that container, if you kill that, the container is gone. Once the container is down, it loses its IP address. You can't guarantee that it would have the same IP address if I restart that container. That becomes a challenging part, which is called as service discovery. To discover where this other service is running. This is one of the biggest challenge. Second challenge, inter-service communication. These two are very important aspects to find out where what is running and how to communicate with it. There are varied varieties of communications across different containers. You can have a synchronous communication, you can have an asynchronous communication, you can have a notification type of communication, you can have a queue-based communication where you publish, the other guy receives it. So there can be n varieties of it. Depending on what would be the type of your application, you would be choosing one of the ways. It can be one-to-one communication, it can be one-to-many communication. Once the order is created, message goes to the consumer, message goes to the kitchen, message goes to the restaurant as well, right? So notifications can be sent to varied type of services as well. So we have to understand service discovery. In Kubernetes, when we look at the architectural diagram of Kubernetes, you would find that in the cluster, there is a component running which helps us in doing that. So etcd is the service registry. This guy maintains what is running where. This is like the brain, you can say that this is the brain of our Kubernetes cluster. A lot of people call it as a key value store. A lot of people address it as configuration of the cluster, cluster configuration map. A lot of people call it as a database of the cluster. This is the one which is actually remembering that containers are running here, here, or here. Where it is running and what is the way we can reach it. So this is my Kubernetes cluster. I'll bring up a cluster like this. It takes some amount of time to bring up the cluster. These days, life is pretty simple. I remember going back 5 years, I was bringing up my cluster. It took an entire week for me to bring up a Kubernetes cluster. But these days, there are a lot of automated tools with which we can bring up our cluster within 5 minutes, 10 minutes, depending on how many nodes in the cluster we have. So there are two varied varieties of nodes in the cluster. One guy who manages the cluster is designated as master. And the guys, those who are actually hosting the workload of the application, they are designated as worker nodes. So these are the three worker nodes, worker 1, worker 2, and worker 3. And this guy is the controller of the cluster, called as the control plane, which would be actually handling the cluster maintenance stuff. It would make sure that things are working fine. That's the responsibility of this. Now we would be creating containers of our microservices and we would be deploying them in the worker nodes. They will get deployed here, but they would be getting managed from here. That's the beauty of Kubernetes. And you can run hundreds of containers in a node depending on how much of resources you're actually asking inside a microservice. Microservice will not have too many processes running in it. If we have too many processes running in that microservice design is not good. So we would be deploying them in a very smaller terms, like very, very small mini applications has to be there. And we would be bringing them up in a Kubernetes cluster. I'll take you to my cluster and I want to show you the processes which are running in my Kubernetes environment. Cubectl is the command line interface with which we can interact with our cluster. It needs two things. It needs to understand as which user I'm executing the command and in which cluster I'm executing the command. If you go back one folder in this my setup, I have a admin.conf file. Let me catch that file and show you. When we bring up the cluster, a configuration file for the administrator is created automatically. And this configuration file has information about the cluster. It has a certificate with which we can authenticate with the cluster. This is the IP address and the port number on which my master node is listening to the API calls which I make. When I execute a kubectl command, the API call of the Kubernetes gets generated and it would be sent on this IP. This is the name of the cluster and we have context created for every user. Like for example, this is an administrator. For example, if Kopal is logging into my cluster and she needs developer level access, I'll create a context for Copal and assign her a developer access and give her a very similar file like this, with which she can authenticate to the cluster and log in as a developer. So we would be having user context changing from user to user, but cluster context would remain the same, because if 10 users are logging to the same cluster, the context is going to remain the same from the cluster point of view. This user named is Kubernetes admin. In the cluster, the name of the user is written like this. This is the name of the user @ the cluster name. And we have a context created with this name. If you look at it, it has this user, a certificate and a key which authenticates that user to this cluster. So when I'm executing a Kubernetes command like kubectl get command or any command, how does it understand that it has to go to this cluster and execute? It could be that I don't have the authority to run these commands, could be a possibility, right? So from administrator or developer point of view, we also need to understand how does the API works. So we can execute commands that goes and connects to the API server, which is the front end of our cluster, and it authenticates and authorizes. First, it will check whether Mamta is a valid user. She is a valid user. Does she have the authority to run get command on the cluster level? If I'm a developer, I may not be able to execute all the commands as an administrator. Administrator has the full capabilities, right? So it does two steps, authentication and authorization. If I'm authorized to execute this command, it will go ahead and execute the command. I am listing the nodes which are part of my cluster. As I showed, I have one master and two worker nodes. Worker nodes don't show up role. That is how it is. It's not that it's a bug that it is showing none. Worker nodes show just like that. Master node shows control plane, comma master, and worker nodes shows just worker. It shows as none. Now this is the nodes which are there. I would have some system processes which would be running in the cluster, which would manage the cluster. Just going back here, and let me try to pull a picture of a Kubernetes cluster. Let me see if it is, it's small. Let me draw these boxes. So okay, let me draw it with hand. That particular box is not showing up to draw the boxes. So I would be having a master node in the cluster, which would be running n number of services. And then I would have worker nodes in the cluster, which would be running the application workload. But my cluster can be virtually divided into multiple virtual clusters, people normally call it as. Virtually, I'm dividing my cluster into more smaller parts. Why would I do that? To segregate my workload, that would be the first need of it. Or else I would do it to even control. I can assign control on those virtual clusters. What do I mean by virtual cluster? Some processes which manage my cluster work on worker nodes, and some of them work on master, gets hosted on the master. So this is an not isolated environment, sorry, my bad. It's a virtually created thing. Like this, there is nothing existing that my cluster is actually getting divided. It is called as namespace in the world of Kubernetes. This is not Linux namespace. There is no isolation type of thing. This namespace helps us in segregating the workload. etcd is running as a cluster configuration map. API server is running my front-end interface. I have my controller manager, which would help us manage my controllers. I have my scheduler, which helps me deciding what would run where end of the day. So these are the processes which are hosted on the master as containers. But they are doing Kubernetes processes. They are actually managing the cluster. Few processes like kubeproxy any networking plugins which we have, like what type of networking we do, the CNI pods would be running. So this kube proxy and CNI are running on the nodes in the cluster. Even here, I would have a kube proxy and the CNI. Even though they are running on varied nodes in the cluster, they are segregated as workload called as kube-system. They are Kubernetes system processes. They are not confined on which node they would be running. I'm saying there is a Kubernetes system namespace in which Kubernetes system processes will run, which will help me manage the cluster. Now let me create another namespace. Maybe dev namespace for executing dev workload. And I will have another namespace called as test namespace for executing test workload. So it's just a way of segregating our workload and having them under one umbrella so that we can manage them better. So this is test and this is my dev namespace. For example, imagine Kishore and say Amar are the two developers, and Nuvan, hopefully I'm pronouncing your names correctly, sorry if I'm not, and Manav, they are the two testers. You guys are in green, sorry. And they are executing their respective workloads. It would get hosted here because they are application workload. They will not go on the master. We don't run application workloads on master. Master already has huge amount of responsibility to play. We would not run them on master. So this is, say, container 1, which is running in test namespace. It has two replicas. So one container instance is here, one container instance is here. X-axis scaling for my container 1 microservice. Manav is running a bigger container C2 and he is running 3 instances of it. Then I will have like this. So what I need, I want Kishore and Amar to be only able to see the workload which is running here. I want Nuvan and Manav to have access capabilities only running here to check the things what is running there. So even though namespace is a virtual division, we can limit the access capabilities on that. So it is providing isolation to one level, but it is spread across the nodes in the cluster. It is not bound to a specific node in the cluster. I can't say my namespace is existing on worker node 1. It is spreading through all the worker nodes. Wherever the container of that namespace run, that is residing on that node in the cluster. So I would be using role-based access control, and I'll make sure that Nuvan and Manav only have access to the test namespace pods, and Kishore and Amar are having the access to the dev namespace. And I would also limit them. I know they can run containers on this node and this node, but the Nuvan and Manav are having heavy workload. They are running so many instances of containers that they are eating up the entire resources which are there in worker 1 and worker 2. Kishore and Amar would get troubled, right? So we don't want that to happen. So what we would do, we would limit the amount of resources, how much I can assign to dev namespace and how much I can assign to test namespace. So at no point in time, more than the defined or assigned resources, these containers can use. So I can say that in test namespace, I'm allocating a 4 virtual CPU and 8 GB RAM. And for dev namespace, I'm allocating 2 virtual CPU, 4 GB RAM. A little bit less to you people. Okay. So when I specify this, single container can utilize 4 virtual CPU, 10 containers can utilize 4 virtual CPU, 20 containers can utilize 4 virtual CPU. It's up to Nuvan and Manav. But beyond 4 virtual CPU, 8 GB RAM, they can't go. So what would happen in those cases? I am having cluster which is having, say, 4 virtual CPU, 8 GB RAM and a 4 virtual CPU, 8 GB RAM. Some part would be utilized by the operating system and all that as well, right? But the amount of resource which is existing in that node, this node plus this node. It is a cumulative thing. Across both the nodes in the cluster, they can eat up this much of space. It could be that in this, they have eaten up 3 virtual CPU and 2 GB RAM. And in this, they have just eaten up 0.5 virtual CPU and 1 GB RAM. It entirely depends on how the scheduler is placing the workload, right? So namespace is giving us a capability to divide the cluster virtually into different isolated environment, and we can limit them with amount of resources the processes running in that namespace can utilize. So this is about the namespaces. Why did I go there? Because when we are going and executing this command, kubectl get pods -n cube-system, you would ask, Mamta, what is this cube-system? Cube-system is nothing but the namespace name. So I am stating, list all the processes which are running in cube system namespace. Few might be running on the master, few might be running on the worker, few might be running on the worker node 2. How can I check that? That also can be verified with -o wide command. So here, if you can see, etcd is hosted on K8000. My 3 nodes out of that 000 was master, 01 and 02 are the worker, right? First and the second worker. So kube proxy, 1 kube proxy running in every node in the cluster. So if I would have had time, like 8 days, how we do a training program, I would have shown you how to bring up the cluster, but we are having just 2 hours of confined time. So I can't dig more deep into how to create them, but this is how a existing cluster would look like. And this is the command to list the system processes in that cluster. If you want to list the namespaces, you can list any type of resource in the Kubernetes cluster with this command. So kubectl get ns would list us the namespaces. The namespace which is present already in the cluster. If I want to create a namespace, kubectl create -f. I want to create a namespace with a file, I can provide -f. If I don't have a file for it, I'll say create namespace, say dev. Go ahead and list the namespaces. You would find that dev namespace is there. I can go ahead and deploy application in dev namespaces, and only dev guys, those who have access to the dev namespace, would be able to see that, list that, view that. You can even control the level. They can create it, they can delete it, they can view it. You can just give reader permissions. A lot of stuffs are there in Kubernetes. Quite flexible. Now, I can deploy an application. I was talking about containers. Our microservices would get deployed as containers. But what am I listing? I'm listing a pod. What exactly is a pod then? Let's try and understand that. So pod is nothing but a wrapper on top of containers. So actually there is a process on the OS level which you have wrapped up on the container level and call this guy as a container. That you're wrapping up in the Kubernetes level and calling that as a pod. Now, pod can be a single container or pod can be a multiple container. Multiple container design, not that good to have, because in Kubernetes, we don't understand the word container. It is not a Kubernetes object. The smallest unit in Kubernetes is pod. So you create a pod, you delete a pod. If I create a pod, both containers will get created. If I delete a pod, both containers would die. So unless and until there is a limitation for us, like I had 2 microservices which I have created individual container images, but if I make them sit separate, they don't function as expected. Network latency is there, or they got to share the same IP address, they got to mount the same volume, and number of types of limitations can be there. When I have such limitations, I place them together. Otherwise, this is the best design. So what is a pod? Pod is nothing but a wrapper on top of the containers on the Kubernetes level. Now, Kubernetes is a very intelligent tool. It just doesn't handle Docker containers. It can handle Linux containers. It can handle RKT containers. So whatever is the container underneath it, being a Kubernetes administrator or a developer, I'm least bothered about it. Kubernetes will handle how to create a container. We have to instruct Kubernetes to just with the definition of a container. Whether it is a Linux container, whether it is a Docker container, everything can be managed underneath Kubernetes. So for us, things might not be changing on the lower level. So how processes are abstracted when we are working in the container level. When we are working on Kubernetes level, containers are abstracted from us. We are not having visibility of what exactly is a process and container. We are working on the high level stuff. But understanding this, and this is pretty important to really work with this. You can learn this and work with this, but if you gain knowledge of these two things, you have the best combination. So I'll pick up this question. Very good question, Amar. I was about to say that. So a lot of people get confused when we say that Kubernetes is deprecating Docker. Docker has multiple parts. Docker has a part for maintaining containers. Docker has a part of maintaining images, volume, network, like this. So we would be retaining this. Container which is running would be a Docker container. We don't need these parts. Kubernetes networking is there. Kubernetes volume mapping is there. Kubernetes, with the help of container registry, manages the images. We don't have to do all these things. So we would be just using the container part of it. It's not that the entire Docker is getting deprecated. Docker is broken down into Docker D and Container D. Container D was the one which is actually handling the life cycle of a container. We will have this component still present. We will not have this, which was managing network, image, and volume. So it is getting deprecated, but it is not getting completely deprecated. Container D would be used, which will manage the container, or which will spin up the container, create the container, whatever functionality the Docker does it for us. That part would be there. Hope that is clear. So don't get carried away with the word that Docker is getting deprecated in Kubernetes. It's not that the containers are getting deprecated. Kubernetes has its own way of managing network and volume and all. We are utilizing that. We are not utilizing these stuffs. So there's no point keeping them in the system. That's the reason we are removing that overhead, whatever is present in the containers, and we are not having them anymore. That would be coming from version 1.22. At present, we are in version 1.21. Recently on April 7th or 8th, I'm not sure about the date, 1.21 came. From 1.22 onwards, this guy would be deprecated. So moving on to, now I know how a pod looks, right? A pod is nothing but a container's definition. Let's look into one pod definition. So this is my pod definition file. I am saying this is a pod, the name of the pod, and every resource in Kubernetes cluster will have a label associated to it. Label is used to identify a resource in the Kubernetes cluster. I'll give some examples where it would get used. Let's now focus on the details of the file. After that, I'll pick labels topic as well. So specification has containers definition. This pod is having a single container whose name is demo-container, and it is coming up with Nginx image. So this image would be pulled from hub.docker.com, and a container would be up and running in any one of the nodes in the cluster. Which node would be picked up is decided by the guy scheduler sitting on the master node. That guy looks at the availability, how much of resources are available in which node in the cluster, and tries to optimize the resources in the cluster and deploy them in the respective nodes. So if I want to create this resource, Cubectl create command is here. And I have the definition file, so I'll give -f. F stands for file. And I would say pick whatever is defined in this file and go ahead and create in this cluster. Demo pod is created. If you go ahead and do Cubectl get pods rather, you would find that the pod is up and running. When I wanted to list the pods in kube system namespace, I did this. Where is this pod running? This pod is running in something called as default namespace. When you don't provide a specific namespace, I have not defined any namespace in the file. It will automatically go and create the resources in default namespace. If I want to run the same resource in dev namespace, what will I do? So if I want to look into the different parameters, for example, a lot of time people think we have to remember all these commands. Answer is no. You should try to learn how to use help like man pages we used to have in the container, operating system. That sort of stuff is there. I want to look into what all options can I provide with this and make sure that it would get created in that particular with those many attributes. I want to provide some -f. I provided this option, right? I provided -f. It went ahead and created the resources which was defined in that. If I want to specify the namespace in which it gets created, I can even do that. Like if I can open the file and in the label metadata section, I can write namespace. Let me try it out. Namespace, spelling is wrong, and I'll say dev. Hopefully we had created dev. Let's try and do this. And let me go ahead and execute the create command again. Created. 2 resources in the cluster existing with the same name. Possible? Yes, because they are belonging to 2 different isolated environments of 2 different namespaces. It's equivalent that there are 2 houses and in both the houses Mamta is there. In house number 1 also a lady named Mamta is there, and house number 2 also a lady named Mamta is there. But 2 resources existing in the same namespace with same name, not possible at all. Now, if I want to list the resources which are existing in, say, dev namespace, I have to use this. If I want to list the resources in just default namespace, you don't give this. That means default as well. By default, the name is default for the namespace. That's the reason you didn't specify -n. So pod is up and running. It has a container running inside it, which is actually running our application. So you can go ahead and describe a resource when you have created it. First command to learn, you can create, you can list it by a get command, and then you describe that resource. So describe a pod. Which pod? Demo -pod. I want to describe a pod residing in dev namespace, then I'll give this. It is saying that it got scheduled in worker node 1. It pulled this Nginx image. After the successful pull of the Nginx image, the container has got created and it has got started. These are the events which has happened with this resource. And this is the entire definition file of my application microservice which is running inside that pod. It is a pod residing in dev namespace. It is hosted on this node in the cluster. It is labeled this way. It is in running status. It has this IP address, and this is the container specification. So when I'm creating a container, actually container got spinned up on worker node 1, and that got wrapped up with a pod, and we are able to see that in the Kubernetes world. Now, Kubernetes will take the responsibility of managing it only when you create a controller. Now you just go ahead and delete this pod. No one is bothered about it. Why? Because kind pod is very equivalent to a container. If you don't create a controller associated to it, no one is bothered about it. So coming to the new terminology, we learned what is a pod. We learned what is a namespace. We will see label. I'll just write it so that I don't forget. And let's now talk about controller. So every pod will have an associated controller. Nginx pod will have an Nginx controller whose responsibility is to make sure that this pod is up and running at every point in time. If I say run 2 replicas of it, it will make sure that 2 replicas are up and running. If I say these 2 replicas have to run version 1.12 of Nginx, it will make sure that both the replicas are running version 1.12. If one replica goes down, it will make sure that the replacement replica, the self-healed replica, comes up automatically. So what is this guy doing? It is helping us maintain the applications in the cluster. Pod is just like a wrapper. It doesn't have that much of intelligence. It's just a redefinition of a container in the terms that the Kubernetes can understand. Intelligence in Kubernetes to manage or orchestrate our application comes from the controller. So this you can think is part of your Kubernetes. If controller is not present, Kubernetes can't manage those things. Brain, heart, whatever you think, right? So etcd is one of the important things. It understands what is running where. Controller is one of the important processes which understands that I need to maintain these things in the cluster. And these many instances of this particular application has to be maintained. Now, if I'm creating a Redis pod, I'll create a Redis controller along with it. The worker of Redis pod is just to maintain Redis controller. Now get this label into picture. We will label the resource of Redis in a way that the controller can identify it to manage it. If I don't have a label, I can't manage that resource. So when we have a lot of stuffs running, a lot of things, just imagine that I have 10,000 books in my library. Will I not segregate them and label them as like fiction, say technology based or drama based or something like that? I'm very bad in reading books, just picked up an example out of the blue. But if I don't label, I would not be able to manage them. That becomes challenging, right? So we would be going ahead and labeling the resources so that identification of those resources becomes easier in the cluster. So I will label this as app Redis. Label is nothing but just a key and a value. And when the controller gets created, it will make sure that it is looking for the pods which are labeled as Redis, app Redis. So it can identify them that, hey, there are one instance of Redis app running in the cluster, and it would be managing them. Same way, this Nginx container would have, say, app Nginx. And this guy will identify the pods, all the pods in the cluster. It will go and check. Whichever is labeled as app Nginx, it is only bothered about them. It would not be bothered about any other pod in the cluster. Now coming to the networking part of it. There is a container running and there is a wrapper pod. I can communicate with it with the help of IP address. Who allocates the IP address was one of the questions from, I think it was from Yogesh. So IP address is handled by the CNI pod. IP address is nothing but handled on the operating system level. So we will have a bridge type of networking in every node in the cluster. From that bridge, this guy would get the IP. So let's see where my pods are running. I want to show you one stuff so that you understand that every node in the cluster has a different subnet range. So if I do kubectl get pods -o wide, I'll list pod of, say, default namespace, and I'm listing pod of dev namespace. Both of them are running on worker node 1. Don't you guys see that they are having the same subnet range? 10.32. If I run 10 different pods and they are getting hosted on worker node 2, they will have a different subnet range. They will not have 10.32. They might be having 10.33 or 10.40. So every node is having a subnet, and you can think my cluster is a bigger network And inside every node, there is a small subnet. My processes which are running in that node in the cluster is getting IPs from this subnet, and all subnets are belonging to a bigger network. So this is normally called as overlay network, which would be connecting multiple nodes in the cluster. It would be stitching up all the network together. So we have different types of networking interfaces. Kubernetes doesn't have networking inbuilt in it. You can have different types of plugins implementing different types of networking. So we would be having overlay type of network of type, say, Calico, Flannel. There are different types of plugin. I may be using BGP protocol, VLAN protocol, VXLAN protocol, how I want to route my packet, how I want to encapsulate those packets, right? So if I have my pod 1 running here and pod 2 running here, they would communicate like this. So these IP addresses are assigned from that particular subnet range on that particular node in the cluster. So I'll not focus on IPs. If you're interested in looking into the networking, in last webinar we had done that. You can just run through that webinar. Today my intention is to cover something else. My intention today is to cover how do I pass a configuration parameter into my application. So today's important topic, or the hero topic, is configuration map. If I have an application, it could have different varied varieties of environment settings. Now, when we were in the virtual machine level, I don't know how many people among you have faced that issue. That when I was working as a developer, I used to deploy the application, capture a VM snapshot, and handle that VMDK file to my another team member who is working in a test team. Immediately a mail used to come, hey Mamta, it's not working in my environment. Why? Because the image which we capture of that VM doesn't grab or doesn't bake in the environment setting into that image. So when I move it to a different environment, I'll have to redo the setting part of it. But when we come to containers, there are advantages that I have container image like this, right? How I have a virtual machines image. So containers image can have the environment settings. And even if I take the container C1 from one environment to another environment, like I was working on-prem, in my personal laptop, I have Docker, I have created this container, and I pass on this container image to Parikshit, and he's running this container in Azure. He would be able to work with it without making any changes, because environment settings, what is needed for the application to run inside the container is already present in that container. When the container initializes, environment settings are redone in the environment in which Parikshit is working. So that helps us attain a lot of stuff, right? It makes our life simple. But we have drawbacks with that as well. Like I'm baking in the environment values inside the containers image. Now imagine there was an environment variable, taking a very kiddish example, sorry for that. Imagine that there was a variable called as variable. This was the name of the variable, and value of the variable is say 10. And this is used in my application. Wherever I specify where, the value 10 will get substituted. This is my environment setting. This environment value is inside containers image. Now something got changed. I got to write 12. Maybe say it was not a variable, it was the buffer value. Doesn't look good. Name variable, right? So buffer value has now increased to 12. If I'm saying buffer has increased from 10 MB to 12 MB, this 12 change when I make, I'll have to recreate, emphasizing on it, recreate my containers image. Because this value has to be changed, and then I'll recreate the containers image, and then this time when I give to Parikshit, in his environment also the buffer size will be 12 MB instead of 10 MB. So For that, what I need to do, I need to recreate the image, and Parikshit needs to redeploy the application. Two-step process. 1, recreating. 2, redeploying. Overhead is too much. It's a costly process. Again, recreating one more image, uploading into the container registry, Parikshit pulling up from there, deploying the application. Difficult. So what we would do, we would not define the environment variables inside the container. Then what other options do we have? Let's figure out what all can be done. So we can write in our kindpod.yaml file where we saw, we can write env there inside the container's definition, and we can supply the key and the value over here. The value was buffer and the key was buffer and the value was 12 MB, right? So initially it was 10 MB. Now it has to be 12 MB. I'll just show you how exactly the definition file looks like. Hopefully I should have fun. Config map dot, okay. Sorry, my bad. Redis pod is the name of the file. So do you see this? There is an environment setting done. What's the name of the variable? Master. What's the value of the variable? True. So wherever this Redis application will start from that image, the name of the environment setting would be done. It would be marked as master as true. So same way I'm saying that name of my environment variable is buffer and the value of my environment variable is 10 MB. Image remains the same. So I'm picking up Redis image and I'm changing the buffer size. So what I've done, I am not changing the image. When I have to give this to Parikshit, I will just change this file from 10 to 12 and I'll hand it over to him. What he would do, Redis image is not going to be recreated. He just needs to pick this, and what command did we execute to deploy our application? Parikshit has to delete the present running pod and he will create a pod with this new deployment or the pod file, say pod.yaml. Now when the pod comes up, the container will have the value of 12 MB for buffer. So what he did one step, I did one step. I modified the file and he redeployed it. I didn't modify the Docker file. I didn't rebuild the image. Image remained the same, the previous image itself. I have just overridden the value from Kubernetes level. So when the container initializes with this, starts with the Redis image, this environment settings would be done immediately after that. So 12 MB would be written inside the container, but that would happen only during the creation of the container. This is one way of defining the environment variable. We have saved one step. I don't have to rebuild the image. I'm good with it. But I have to make the file changes. Suppose this buffer value is used in 10 different files. It's foolish in my part to go and change this variable in 10 different files and then give that 10 different files to Parikshit to deploy 10 different applications, right? So it would be so much of overhead. I have to go and identify which files are having that environment variable, make the changes and provide them, upload them in the repository, and the team would pick up from there and deploy it. So we would move one step ahead. Instead of doing that in every single file, I can have configurations saved as a resource type. There is a type called as how we have a kind pod. Like that, I have a kind of resource whose name is config map, a type configuration map. This guy helps me to define resources, any environment setting for those resources inside this. So you can think this is a central location. These config maps are per namespace level. I can have multiple config maps. It's not like one-to-one in dev namespace. I can just have config map 1. No. I can have multiple of them. In config map 1, I have defined 3 variables with their values. In config map 2, I have defined 2 variables. I can do that. And these 3 variables are used across 10 different applications. 10 different files are actually reading these variable values. So I change it in a central location, it will automatically be percolated down to each of the applications. That's the advantage of it. So you can think like it is like a central placeholder. You can see here, it allows us to decouple the environment specifications from the container's image. We can define it from the command line. We saw the first one. You can define it as environment variables, and you can write it in a configuration file like a config map and use it inside the container. I would like to show that. So here we would pick up a simple example. There is a config map. Let me show you how you define that. I'll create a kind config map. It has a metadata. Every resource will have a metadata associated to it. The name of the config map is my config, and it is in default namespace. So why it is having a specific namespace tied up to it? So whenever any pod wants to use the resources or use any of the configuration parameters, that config map has to be of that namespace. Otherwise, it can't reference that config map. That's the reason namespace is a mandatory parameter in this. When you have the different variables, they are starting with the section data. This is my variable and there's a value associated to it. So this is a key and this is the value. My data is called as hello world 2. So if I go ahead and create this config map, let's try and do that. As simple as kubectl create with -f config -map.yaml. It is already existing. Awesome. Let me just go ahead and do that. Get my CM. Yep, it is already existing. Sorry for that. And this configuration map, if you go ahead and describe, any resource can be described. Let's describe this. So while describing, you will say the type of resource and the name of the resource. So I'm saying describe config map named my config. So here the config map is having data, the my data hello world 2. How do I use this inside a pod's definition inside the container? Let's try and see that. So I have another file which is actually using this. Config map -pod.yaml file is there. I am creating a kind pod, the metadata, the name of the pod, the specification has a container, the name of the container, the image, and the port number on which the container is expecting the packet. In the environment setting this time, I didn't had a name and a value. Now what you have the name. The variable name inside the container is CM. But it is getting value from whom? From a config map key reference. I'm referencing a config map key and I'm taking the value from there. The name of the config map and which key I would be referring. I can have n number of data inside that. If you look at the description here, if you just see here, it says I have one data. I can have multiple data inside it. If you go ahead and look into this file, I can write another data, like in YAML we have to be very careful about spaces. Let's take as this. This is another data associated to the same configuration map. My configuration map is now saving 2 environment variables. If I want to apply the delta, I would give this way. I have to specify the file name and it would go and update. Now let's list our configuration map and see what it says. It would say I have 2 data. And if you describe as well, you would be able to find there are 2 data in it. But I am referencing only one particular key inside that. I am not referencing both the keys. I am saying, sorry, not this file, the pod file I wanted to show up. Yep. So in this, I'm saying from this configuration map, pick this key. And that key's value would be assigned to this variable. Let's try and spin up this pod and see whether it has that environment setting. How do I create? I have a file. I'll just pick up that YAML file and I'll give kubectl create command. Pod will get created. Kubectl get pods. Let's first list that. Yes, the CM pod is up and running. And I can connect to the pod with kubectl exec command. I want to interactively open a terminal inside my cm-pod and I want to do print env. I could have given -- as well because I'm being a bit old in executing these commands. You have to give -- starting from some specific version. They have not deprecated this way of execution, but in future it would get deprecated. So let's see this. Can you see this? CM value inside the container is hello world 2. So if I'm going and changing, so what we thought that if we have to change, what all things we have to do, let's figure out that. So now, earlier I had to change 10 files and Parikshit had to deploy 10 different application files. But now I'm changing my configuration map. One change. But redeployment remains the same. We have to redeploy all the applications which are referencing this configuration map. If that value or the key is actually the variable environment settings is used in 2 different applications, I'll have to redeploy both my applications. I will be bound to do that. Otherwise, that change will not take into effect. So let's see how we would do that. Let's edit our configuration map from hello world to say hello X. Save it. Again, do that apply command so that you can apply the delta changes. This time I will not list it. I'll directly describe it so that I can just look at the value which is there. It is showing up that configuration map is updated with the value called as hello X. But if you go and look at your application, it will still be having the old environment settings. Why? Because these type of things would be only picked up when the containers are getting created. What is the meaning of these type of things? If we look at the config map file, it entirely depends how we have defined our configuration. If I have referred like this as an environment settings, these would only reflect during the creation of the container. After that, if you make any changes, it's not going to reflect inside the application on the fly. Not possible. So what we would go and do, if I want to delete a resource, I can delete a resource which is defined using this file. Let's do that. Once the deletion is done, you would see that deletion takes a little bit more time because it has to delete the entries from several places. I'll go ahead and recreate it. This time when you create it, it will pick up the new value of the environment variable. So I've saved one step that I don't have to go and modify 10 different files. That's one of the advantages to it. There is one more flavor of it using the configuration map as a volume. So I will have a configuration map file. I want to mount that as a volume inside the container so that if changes are being done on the fly, that would be reflected. So let's see how do we do that. So here at least redeployment was needed. Here nothing is needed. You change the configuration map on the fly, that would be reflecting. So that would be the last topic for the day. Let me show you the files and then I'll go ahead and execute it. So in such cases, how do you define the configuration map? So I am defining a content of a file which would get mounted inside the container. So a file content is 2 lines. I'm creating a kind config map whose metadata contains the name of the configuration map and the namespace, and it has a data which is named as the key redis-config, and there is a pipe. From this pipe till the next attributes definition, it's the entire content of the file. So I have 2 lines in my file. One says max memory is 4 MB, and there is some max memory policy associated to it. I've already created this config map, so let me do get cm. You see it is existing. Let's pick up the name and give a describe command with it. You can see these 2 lines are reflecting. Now, if I want to use this in the container and I want that to reflect on the fly, see, a lot of application may need restart for taking those changes into effect. Few applications parameters may be reflected on the fly, and application is also intelligent enough to pick those up. That's when we can utilize this. So I would be using Redis. Let me see what's the name of the file. redispod.yaml if I'm not wrong. So here I'm using it. I'm using it as a volume. So this is my container. One variable is defined in a traditional way, key and a value defined in the file. Other variable is mounted as a configuration. If you see, I'm referencing a config map here. I'm saying config map name example redis-config. There are items, the key and the path. So this key would be picked up. Whatever data is written, that would be written into this path. That means those 2 lines would be written in redis.conf. And where will this redis.conf be present? It is mounted at this path. So this is config is mounted as /redis master. So I would be having redis.conf file present in /redis-master inside the container. Let's see this. If I create it, what would happen? Let's execute the create command with -f and give the file name. Cubectl get pods. Pod should be up and running. Let me go ahead and connect to the pod this time. Kubectl exec-it, and the pod name is Redis. I'll give that, and I can cat what? Redis hyphen, what was the path of it? Somehow I forgot. So let me just check the file once. Redis-master. Okay. So the file is present in redis-master. So I'm just giving the path, and the file name is redis.conf. Let me cat the file. It is having 4 MB and it has this values. So the file content inside the container is this. Now let's try editing this value in the configuration map and see whether it reflects. So what we would do, we would go ahead and edit our Redis configuration file. From 4 MB, I want to make it as 2 MB. My max memory size is reduced somehow. Make the change. This change is only done in the file. Apply command will apply that changes into the cluster. So let's reflect that into the cluster. Let's try and describe and see once that the changes are reflected. Yes, to the configuration map it has reflected. Kubelet sitting in every node in the cluster takes the responsibility of updating all the pods which are referencing to this configuration map. So there is a timer associated to it, and after a while you would see that it is reflected. Can you see this? It's already reflected to 2 MB. So once you change the configuration value in your config map, it has automatically reflected from 4 MB to 2 MB. That's the beauty of using configuration map mounted as a volume. And the file content got mounted as a volume. I'm just opening this file again so that you people can look into the content of the file once more. So I am mounting a volume called as config at this particular path. That config is nothing but a config map, the name of the config map, and the key which we are referencing. And this is the path which would get created in Redis master. And that is what we went and checked. It is reflecting on the fly when we are making changes. So that's the beauty of Kubernetes. If I have a configuration setting and I don't even want to redeploy my application, use the configuration map as a volume inside the container. You make change here, that would reflect here on the fly. No redeployment needed at all. But your application should be intelligent enough to pick that on the fly as well. So this was all about today's demo. I wanted to show this. This is one of the topics in CKA and CKAD as well. That's the reason I had picked this up. So hopefully you liked the demo. So how did it go, Shivam and Kopal? Hopefully people are good. You guys are there?
Yes.
Yeah, Shivam. So after this, we have a few slides depicting what exactly is covered as part of Kubernetes administrator track and a Kubernetes developer track. So as a Kubernetes administrator, we would learn how to set up a cluster, how to build up the entire cluster, how to have role-based access control in the cluster. Dev guys would be able to access the dev workload. Test guys would be able to access the test workload. And we would be using a kubeadm tool to deploy the cluster. We would learn how to deploy highly available application, do different sorts of networking, mount different sorts of volumes, file system, block storages to that, and restrict them with different policies like, do you need to retain the data? Do you need to reclaim the data? We can do n number of things with that. We also have topics like troubleshooting, because administrator needs to have a lot of knowledge about managing the session, the entire cluster. So he or she needs to know how to work with nodes, how to work with, say, what goes wrong, then how to fix that. All that understanding on the cluster component wise, that knowledge is needed. And obviously how the workloads would be scheduled. You will have the scheduler in the master and you're the administrator. It's under your control. And we covered this one small part of it in this 2 hours. So like that, there are n number of topics which needs to be covered. Administrator track is a bit heavier track. Developer track is little bit less compared to the administrator, but most of the time you would find that people do both the certification because they overlap with each other so much that people can target both the certification in a week's time. I prepare for both of them with a little bit of delta. So core concept remains the same. What is a pod, how deployment controller works, what is a label, what is a selector, and all. I was discussing about 2 containers residing in the same node, same pod. This is here. We covered configuration map. I mentioned that it's a common topic. This is here. What are different types of services, how to restrict 2 pods to talk to each other. Traffic policing we can do using network policies. If I want to mount encrypted data inside containers, how do we do that? And how to mount volumes inside container. That would be the agenda for the developers. So developers have a little bit lesser scope. Understanding from application perspective, one biggest thing is how to decide whether my application is alive, it's serving, or it is not ready. If it is not ready, I should take some recovery action, fallback actions for it. So we need to understand debugging from applications perspective, monitoring from applications perspective, logging from applications perspective, aliveness check or readiness check from applications perspective. So that is one of the most interesting topics I feel from CKAD perspective. Why we are doing Kubernetes. Here you would find n number of companies I've listed in the next 2 slides, those who are like working on Kubernetes. You can see Tinder, the dating app, which is pretty famous. They are running 1,000 nodes, 15,000 pods, 48,000 containers. New York Times is also moving, or it's already running on Kubernetes. Airbnb is running on Kubernetes. Reddit is running on Kubernetes. The most famous game which made which became so, people became so crazy, Pokemon Go, back in this Kubernetes. So a lot of companies are running production environment in Kubernetes. That's the biggest advantage. The scalability, the high availability is too high. We have n number of job openings in the market. Day by day or year by year, you would find that they are increasing exponentially. You would see the percentage. It's not 10%, it's not 15%. 2,125% increase in job for Kubernetes has been seen. And that is because it is one of the highest demand. How no one was left untouched with a VM, no one would be left untouched with Kubernetes and Docker or any container. That's the reason everyone will someday or the other, either as a tester, developer, DevOps guy, as an architect, they are bound to learn this technology. You don't have a choice left with you. Quicker you learn, more demand you have. N number of types of profiles are looking for Kubernetes job requirements. So these are few of the varied places where people would be looking for Kubernetes engineers, DevOps, as a DevOps role, as an architect role, as a full stack developer role, and varied varieties of openings are there in the market. So this was a brief about how Kubernetes is doing and why we are forced to learn. You like it or you hate it, but you will have to use it. So that was all from my side.
So Mamta, I have a couple of questions for you on this slide.
Yeah.
So as we have seen that there is a huge increase in demand of Kubernetes job in the market.
Yeah.
2,000%, more than 2,000% is a huge rise.
Yes.
So now from the different participants' point of view, for example, some of them are DevOps engineers, some are, let's say, software architect, cloud engineer, or they are developers as such. So how do people start with Kubernetes? Like, what are the deltas which they have to learn from different job profiles? So let's say if I'm a full stack developer, then what is my next step? Where do I start from? How difficult is it going to be for me to understand it? Or we are definitely sure that the way you have explained with all the diagrams, it makes sense. But what are the deltas which various participants from various job profiles they need to know?
So whoever belongs to any of these roles, I don't think they will not be knowing what a VM is. If you know what is a VM constituting of, like a CPU, it has RAM, it has disk, and you understand that process runs. A lot of time people come from different operating system background. It's a bit difficult for them to understand this as well. But if you know a virtual machine, it's very easy to translate everything to containers, because containers are nothing but a shrinked form or a lightweight form of a virtual machine. So we always, like today you saw that I started with microservice. I wanted people to get the use case. Why containers? If you understand why containers, our applications are not huge that they will run in VMs. They are very small in size. If I don't want to run them in VM and lose on resources, so I will deploy them in containers. And when I have huge set of containers like this, I'll manage them with Kubernetes. So we always start, like I'll show you the outline, what we have for our course, which we normally do, the workshops. We start with introduction to microservices. We understand containers basics. We do a lot of hands-on exercises here. How to create a Docker container, how do we networking across them, how to mount volumes in it. And then we take people to orchestration level. We teach them how to set up a cluster. We teach them how to deploy application. We teach them what are the roles and responsibilities of individual processes running in the cluster, which makes cluster as a cluster. We teach them the networking which happens in Kubernetes. We teach them how to maintain high availability or scalability in the cluster. So we always start from this basic point. If you start from here, your journey to Kubernetes would be much easier. If you directly jump onto Kubernetes, it would be a bit difficult to understand on the lower level. Maybe you will be able to handle the workload, But if something goes wrong, digging deep into the issues and finding out the root cause analysis would be difficult. So we should start with microservices and containers. Yeah.
Okay. And also from the developer's point of view, let's say how much percentage of networking do they have to understand? Because as we know, developers may not be having the prerequisite knowledge for the networking. So do we cover that, or do we start from the scratch, or what do you do? How do you take this forward?
So Kubernetes has networking as an add-on plugin. So you don't have to deep dive into the things. If I'm an application guy, I've deployed an application, if I only understand whether this application will get an external traffic or there is an app too which will get traffic internally, if I understand the differentiation between these two, the networking basics can be taught. Only that understanding is needed. The network stitching part is beyond the scope of Kubernetes. For that, you will have to do a CNI course, which is like a Calico course or a ViewNet course or a KubeNet course. Here, we would be picking up the plugin and deploying the network. We will understand how the subnets are there, which IP addresses are there, but we would not be digging more deep into that. So it's okay for application guys or the administrator guys, those who don't come from a networking background. Like I'm also not from a networking background, right? I myself have done C++ development for 12 years. So it was still okay for me to learn it because it's not that deep into.
Okay. And there is something which there are some questions which everyone asks. For example, as we understand that the trainings are different. For example, a lot of trainings which the participants have joined before, or maybe they have some sort of let's say there is a perspective or perception is there that the trainings are different from production environment. Like production is way different, and if we take some training, if we learn it in the training, then we cannot apply that in the production. So what is this? Is there something which we are doing in the trainings, or how do we you can say bridge the gap which is there between the tutorials versus the production environment? How do you take this forward?
Yeah, so because we come from a consulting background, we do a lot of consulting projects ourselves. The curriculums and all, when we are preparing, we are keeping that in mind, that a person who comes understands the exam perspective as well. And we are not just focused on exams. We try to cover a lot of topics like ELK stack or a stateful application or a daemon set type of application is out of the scope of both the courses. But we cover this because end of the day, when you're going back to a production cluster and you don't have a logging or a monitoring tool, that's near to impossible. You will have to have a stack which will be monitoring and logging for you. And if you don't know how to set that up, you don't understand how it works, it would be difficult. So we try to incorporate these different varied varieties of stuff so that it makes your life simpler when you go back and start working on it in a real-time environment. So we try to bridge the gaps by picking up real-time examples and real-time stacks we pick and we deploy in our class environment itself.
Okay, that's great. And also, if you can tell us about the practice test which you have, or what is the, let's say after the training, do we provide some exam questions? How do we do the labs? Where do we do the labs, and so on? So, but if you have that in the slide, you can definitely take it when the slide comes, or if you want to answer it right now, you can.
So I don't have a separate slide for the environment. We ask everyone to come with an Azure account because we have picked up Azure as the cloud provider. I would expect everyone to spin 3 VMs. A lot of people are new to cloud, so we do hand-holding in making them create 3 virtual machines. And in the class, we would create VMs and bring them as a part of a cluster. Initially, we start with 1 server because we have to learn Docker. And then we move on to the 3-node setup. By the time people are a little bit comfortable with our creating servers and all in cloud, and we use this setup to do the classes. So everyone comes with a trial account of Azure, and we use that $300 or $200 rather for the lab setup what we have. About the practice test, in exam we get 17 to 19 questions, hardcore hands-on questions. So our lab exercises are also made in a way that you will not be just confined for the exam, you will go beyond it, but you would have tasks which are already asked in the exam. And practice tests are like what people have got questions in the past. We have tried to consolidate that and then have question and answer both for it. So out of these two practice tests, most of the time you will get all 16 or 17 questions out of this itself. So they don't change the exam pattern that frequent. So you would say that all the questions would be ticking in the exam for you if you do the practice test.
Very good. That's extremely good that whatever we are doing, that itself will translate into getting certified as well, along with the knowledge part.
Yeah.
That's great.
And this just to showcase that we are going an extra mile. We're just not focusing on administrator or developer type of courses. We go beyond that so that it covers the topics which are from the real world point of view, from production point of view and on. So that's the important point. It's just not focused on getting you certified. You will get certified. A lot of time people come with the intention of only getting certified. I hate that. If you learn the things scratch from basics very well, you're committed, you will certainly get certified. Your intention is not passing the certification. Your intention is to gain knowledge. If you have that knowledge, passing certification is never a question, right? So our intention is to make you capable enough that you learn a lot of basics that you can crack the exam without our help. That would be the intention what we have behind. So that.
Thank you so much.
Yeah. Thanks, Kopal.
So much. It was a really, really wonderful session. So as we are, I think, on time, we have completed this session. So the session was really, really knowledgeable. I'm pretty sure everyone who joined us has enjoyed this session. So just to give you that, as I mentioned earlier, before we started this webinar, that we are a training and a consulting company. So we also are coming up with a training on CKA and CKAD combination of both. So in case if you guys are interested just in CKA, the batch is starting from May 1st onwards, which is going to be for 8 weekends, 4 hours on Saturday and 4 hours on Sunday. And the CKAD will be followed up with that, so which is going to be for 10 weekends and in a similar fashion as 4 hours on Saturday and 4 hours on Sunday. So, and yes, we used to do a lot of corporate trainings, and the success rate, even people getting certified, it's in huge number. Now we recently started with the open batches. Looking at there is a lot of requests that Mamta is getting, and we as a company, we are getting a lot of requests on CKA, CKAD and on CKS. So we started this as an open batches as well. And that's the reason like we guys have been doing multiple trainings in open batches too. So you guys can always go onto our website and keep updating yourself with the new courses that we are coming up with, the trainings that has been scheduled in near future. And yes, the cost for this CKA and CKAD, also I would say the CKA is 390 USD, wherein the CKA CKAD combination is 490 USD. And yes, we have been getting a lot of great feedbacks in the open batches too, not just in corporates. So these are a few feedbacks what we have got from our participants who have attended our webinar, our trainings in past. And yes, Mamta would be the trainer for this particular training, which is going to start from May 1st onwards. So I would request you guys who are interested, please go ahead, enroll yourselves. And as we guys have really reworked on the price as well, just to put it across to you all, looking at the pandemic right now. So this is a great opportunity wherein you can, looking at this tough time, you can just keep yourself at par with knowledge too. So thank you so much, everyone. Thanks a lot once again for joining us for this webinar. And thank you so much, Mamta.
Thanks a lot, Kopal. So few people were asking about the discounted rate. Guys, this was already higher price was quoted for this course because it's a 8 weeks program, and we have already discounted this for the webinar, and the discounted price is $390 and $490 in a combination. So if you're targeting both the certification, you can buy the bundle package, and if you're targeting only CKA certification or CKAD certification, then you can buy them individually from us. So this particular webinar was just a small flavor or a trailer of our training program, and we would be conducting 8 dedicated days of session for CKA, and CKAD would be add on 2 more days to it, so 10 weekends. If you dedicate with us, we would like you to ramp up for the upcoming latest technology. So that was all from our part. Kopal and Shivam, if you people have any questions to be answered, just let us know.
So just to add on again.
Sorry.
I'm sorry, go ahead.
I was just adding that those who are interested can share that email ID in the chat window, and we will share the required details with them.
Kopal, hope so you're making a note of the email ID.
Yeah, Mamta.
Yeah, thanks. So any other technical queries as well, if you people have, and you're still online, you want to ask any questions, we are open for it. Fine, then if we are all good, shall we close the session if we have noted down the email IDs and the details of the people those who are interested, and hope so you people like the session. We would upload the recording in YouTube as well. In case you want to refer it sometime later, you should be able to do that. Thanks a lot. Thanks, Asif. Fine, then let's close the session, team. Kopal and Shivam, shall we close the session?
Yeah, sure. So I think we still have 8 participants online, but I think we have all the topics covered and all the questions answered. And those who are interested can drop the email address in the chat window, or can also reach out to us on the cell number which we have posted over there, or on the email address, or just maybe you can directly message Mamta or maybe me on LinkedIn as well, right? And we'll see you soon. Thanks for joining in, and stay in touch for upcoming webinars.
Yep. Thanks a lot, guys. Good night. Thanks, team. Bye.
Thank you so much, everyone. Thanks a lot and stay safe.